This is the second in a set of videos on my V8 hot rod engine software simulator. Please excuse me, I am basically going to read these charts since they are very specific instructions on how to use the simulator. Go to my GitHub, the link is shown here, and download the file blank GUI engine model for upload.xlsm. When you get to my GitHub directory, click on the file name, which shows the subdirectory V8 engine dyno, and then the actual file name blank GUI engine model for upload.xlsm at main. Click download. When a version of Excel opens up, it is on the internet. Click download file in the blue box at the top of the page. This will download a copy to your local downloads directory with the same name. The macros will not run on the internet version, so you have to download a copy. This is an Excel file, so you will need a copy of Excel on your local computer. Find the file in your Downloads folder and open it. You will see a yellow highlight that states Protected View. Click the Enable Editing button. Be aware that there is a risk that someone may have tampered with the files if they were able to get around GitHub's protection. A basic check is that it is 35 kilobytes, but this is a very basic check. Next, you will see another yellow text box at the top that states Security Warning, macros have been disabled. Click the Enable Content button. Now the GUI is fully functional. Note, row 1 has numbers. These will be used to designate which column you want the simulator to populate with the results. Click the Start Simulation button. It should be obvious, but is located in column B, row 3. You will now see the following screen. Note the blinking cursor in the blank box next to engine name. Type a description of the engine. In this example, I typed Hot Rod 10/22 Hemi. This is the latest publication of the Hot Rod magazine that I just received, and I also found this article on the internet and provide the link later. So this is a sample engine that we will use as a test case. Next, click in the empty box next to input an integer, etc. On some computers, the tab key will work. The foolproof method is to click in the box and type 1. Please excuse my spelling errors that I have just seen. Next, click in the empty box next to cubic inches. Type 511. Continue this process until you have the GUI populated as shown. Press Run Simulation and column 1 will be populated with the results. Before I show the output, I also reran the simulation with a 2.42 intake valve because the article was not specific which size valve was used in the stage 5 head, and there are 2 choices. So I repopulated the GUI. This time I included 2 for input an integer, so the output will now be in column designated with 2. All the inputs are the same except the intake valve diameter is now 2.42. Hit the Run Simulation button. After hitting the Run Simulation button for the second time, you get the following output. Note column D has the output for the simulation with a 2.25 valve. Column E has the output with a 2.42 valve. As you read down those columns, you do see that it does make some difference, as you would expect. Maybe not as much as you expect, but it does make differences as you would expect. In column G, I went to the magazine article and I entered the values of the maximum RPMs for torque and horsepower and the actual maximum horsepower and maximum torque. Next to that column, in column H and I calculated the errors in percent for column D and column E compared to column G. This engine was not part of the data set that was used to generate the model. It shows a random test case that achieved decent accuracy with only basic engine design parameters as the simulator input. Here are the links. The first link is the actual article from Hot Rod Magazine. The second is a very similar engine, if not identical, on another website.